Hello and welcome to the Cobalt pre-NAB webinar. Here's our agenda for today. We'll start with the description of the demos in the Cobalt NAB booth, and we hope that we see you all there. Those will include the demo of the Indigo ST 2110 solution, a new technical feature supporting the reverse invest-on mapping, and a multi-link RIST seamless switching demonstration. Then we're going to jump into technical discussion of the Indigo solution, the SDR to HDR conversion solutions. We'll talk about generation and insertion of SCTE 104 and SCTE 35. We'll talk about a little bit about RIST, and we'll give you some product updates. Let's jump right into the 2022 NAB booth demos. The first demo is going to be an Indigo ST 2110 demo, where we're going to show you the ability of Indigo to ingest and output 2110. So we'll have one Indigo board coming into with an incoming stream, an Indigo board with an outgoing stream, and a Fabrics, which is a piece of test equipment to show how good the stream is. And that's all going to be combined into a multi-viewer. Next demo is going to be a RIST multi-link demo. We'll have a pair of an encoder and decoder connected through a pair of Ethernet links. We'll have one channel that's a single link and one channel is a dual link. And you have a really nice blue switch over there. We're going to be able to plug and unplug that link to show it coming down, and you see no glitch. The final demo is something we're doing together with Technicolor, is the Reversible ITM demo. If you recall, or if you're familiar with this technology, SL-HDR1 takes an HDR signal and converts with SDR plus metadata. We also have technology that will take SDR and convert it up to HDR. So if you're doing that, you start with SDR and you end up with SDR. With the Reversible ITM, the SDR is exactly the same. So we're going to show you and prove it to you through the diagram that's in there. So if you're interested, please come to the Cobalt booth and you'll see that in action. Now let's dig into the Indigo ST 2110 solution. Indigo is a factory installed option available for the 9904 UDX and 9905 MPX video processors. So it basically adds native ST 2110 inputs, outputs to these cards. So you have now a native 2110 solution that does everything the card does, but with input and output makes it a lot simpler because it's directly integrated into the card. All the features of the cards are going to be available. All the 3D LUTs and scaling and all of that will be available for ST 2110. And as a bonus, you have the SDI inputs and outputs that also become available. So you can use this as a gateway in addition to being a native 2110 processing board. So a little bit more detail on the solution. The solution will feature two dual 25 gig interfaces. So you can do native 4K and Y2 because you can have ST 2022 dash have seamless redundancy, just like RIST. We will have support for NMOS, ISO 4 and ISO 5. So you throw that in your network, will be automatically discovered and becomes a very simple, very cost-effective solution for ST 2110 processing. Instead of putting multiple boxes, you have just one box. As I said, the functionality of the devices are going to be the same. For the 9905, you have quad up to 3G, and for the 9904, you have 4K. The 25 gig interfaces allow you to run 4K. And now I'll hand off to Cris to talk about the 9904 UDX. Go ahead, Cris.
Okay, so this is, as Ciro just touched upon, the 9904 with the Indigo capability. This is a platform that we've had for some time now, but as you see here, it has a whole list of features that have been sort of updated. They keep getting added to the card. Indigo is one of the options and now is part of this platform. But what is very unique about this card is that we natively support from anywhere from SD all the way through 12G or Quad 3G as an input or output. And on top of that, if you see the blocks that are within this diagram, there's a lot of standard default features that are supported within this card that makes this platform a very robust, more like a Swiss Army knife that, no matter what you throw at it, any sort of changes in your workflow, this particular card will be able to adapt and quickly enable you guys or anybody to do any changes to the workflow. For example, everything that you see here in the black writing here within those blocks is all default standard features that are supported. Anything that's in the blue, these are options that you can enable through a license key. So even if you have the card for some time, you can easily request to have a license that can be added in the field. Or if you want the factory to perform any of the upgrades, you can have this sent back to us. But what is very unique about this is that we can support multiple formats. And as you see on here, the ability to do color correction, manage logos, 3D LUTs, manage different profiles for HDR, and then also being able to encode and process Dolby and do all the processing for audio and embedding, de-embedding, including supporting level A and level B. This platform is a very robust system that anybody should have in their toolkit. So again, as you see here, it's a very flexible in terms of the inputs and outputs that you have, and then also the SFPs that can be adapted to this card for any type of workflow. Next slide. And then as a sort of continuation from the 9904, now we have the 9905, as Ciro also touched on this product. This sort of adds on that flexibility that the 9904 just presented, but now instead of just supporting one channel, this product itself supports up to 4 independent channels that behaves as if you had 4 cards in one card. What is very unique about this is that each of those different channels can do its own embedding, de-embedding of audio. By that I mean you can process AES or MADI, and you can also use the SFP cage to have any of the audios that you may have embedded on a fiber connection to be brought into the card process, and then you can come out either fiber or you can come out SDI baseband out. You also have an HDMI out that can be basically selected with any of those different channels that you're processing. And by default, this card offers the ability to support 3D LUTs. One of the popular ones that we're now supporting is the MVC LUTs as well. And you have a whole list of different options that we support on this, similar to the 9904. So if you have any application where you need to do 4 channels of up and down cross conversion, color correction, processing audios, this particular platform allows you that flexibility, and it gives you the robustness that you need for just about any workflow. And again, just because it's a 4-channel doesn't mean that you cannot use it as a 4K at some point. We do offer a license that can be upgraded on this card that allows you to take this 3G system and make it a 4K if needed. But at that point, now it becomes a 1-channel card just because of the amount of bandwidth that is needed to process 4K. And again, this is the 9905, and it's our quad path multi sort of feature platform.
Thank you, Cris. Now we're going to talk about HDR and SDR conversions, because this is one of the things we're going to be showing at NAB. So don't get scared by the math. Let's talk about static conversion. In static conversion, you take every pixel value and you map it onto another pixel value. Just change for any value of the pixel, you get another value. In order to speed up, you do this using lookup tables. And they are called 3D lookup tables, 3-dimensional, because as you see in the math over there that I told you not to be scared of, each function takes the value of the 3 pixels. So that's the best way you can do. And why a lookup table? Because you have to do that very fast at 4K speeds, so you need to look it up. You can't actually do the math. So for 3D LUTs, there are a number of predefined LUTs today. Predefined means someone went and designed that. The most famous are from BBC, which you have to pay, and NBC Universal, which are free. You can also have some third-party software that can generate those lookup tables, or if you're sophisticated enough, you can also roll your own. We support all of that. Static LUTs are supported in both the 9904 and 9905. I'm showing here a 9905 GUI for that, and you can have either the BBC or the NBC Universal. You can put your user, or you can have external control. So the point here is static LUT. Every pixel is converted to exact same value of another pixel, always. So it's only dependent of the value of the pixel. Now, LUTs can do SDR to HDR or HDR to SDR, just static. Let's talk about now dynamic conversion, which is where you can get the best possible quality. And let's start with SDR to HDR conversion. So the best thing, the clear scenario where a dynamic conversion is better is, let's say, a sports match that starts during the day and finishes at night on illumination. So the lighting changes. So the best conversion changes depending on the content. So static conversion will give you an average value. And but dynamic conversion will adapt it. So dynamic conversion is available in the 9904 UDX product. And there's two modes. There's SDR to HDR and there's HDR to SDR. So let's talk about SDR to HDR first. This, technically, people call this up conversion, but it's not really correct. It's called inverse tone mapping. And we use Technicolor's intelligent tone management, which is the same acronym, ITM, but that's what it is. So if you have an SDR signal, and when you want to convert that to HDR, the HDR information doesn't exist there. It wasn't captured. This is just like converting black and white to color. It's just not there. So you need to make it up. Normally, you have a trained colorist to go look at it and say, okay, this is how it should look like. That's the dynamic way. Technicolor use machine learning algorithms to train the algorithms from the colorists and came up with an algorithm. So this is a fully automated algorithm, but you have tweak the parameters. And once it converts to HDR, there are multiple options for the HDR output. So that's the best thing you can do, SDR to HDR. Now, what about the other direction, HDR to SDR? Again, you have LUTs to do that if you want to do static. But the best thing you can do there is something called SL HDR1. Again, an algorithm from Technicolor, but that's the standard because it's now adopted even in ATSC 3.0. So what happens there is that you take the HDR signal, you convert it to SDR, plus some dynamic frame-by-frame metadata. So it's a dynamic conversion, but there's also this metadata. Some legacy devices will not know about this metadata and just display the SDR. A new device that understands the metadata can then map it to HDR, and in fact, even adapt it to the kind of monitor you're using. So what you have there is a single layer signal that has both SDR and HDR. And it's just like the old black and white and color TV. You had the black and white TV and the color information a subcarrier. If it's a black and white TV, it doesn't get it. If it's a color TV, you went to the subcarrier and got the color information. Same thing here. You have some metadata that if you don't expect it, you just ignore it and have an SDR signal. If you're looking for it, if you're an HDR device, you pull the metadata and you reconstruct the HDR signal. So in SDI, this metadata is carried on the ancillary data using SMPTE 2108. Now, what's new about this? The reversible ITM. You combine those two things, right? You take an SDR signal originally and you convert to HDR. So inverse tone mapping. SL HDR1 converts the HDR back to SDR plus metadata. So if you do those in sequence, you start with an SDR and you end with an SDR. But with reversible ITM, it's going to be the exact same SDR. It's almost like take an SDR signal and add metadata to it to map it to HDR. This is done in 2 steps, and we use SCTE-2108 metadata into the original HDR signal, which originally didn't have SCTE-2108 metadata, and that makes the SDR the same. So if you're interested in, if that's a workflow you're interested on, this will be on display at the Cobalt booth. All right, now let's change gears and talk about ad insertion, because if you're on TV, ads is what pays the bills. So SCTE 104 and SCTE 35. What's that about? SCTE 104 is a control protocol. It's something that the traffic systems uses to signal ad boundaries. And there's 2 ways of carrying that. You can carry it over IP, 104 over IP, using a TCP connection on a low latency network. So it's a way for a traffic system to signal something. Hey, put a marker here. Or you can put it over SDI using SCTE-2110. So SCTE 104 is control, and it happens either over TCP or inside the ancillary data on the SDI. SCTE 35 is the data standard. That's what you put in the transport stream. So 104, the whole purpose of 104 is to create the 35 on a transport stream, and that is to control an encoder. The content of both of 104 and 35 is exactly the same. One maps directly into the other. One exists in the IP domain, SDI, and the other in the transport stream. We support all of that. We have our inserters taking an SDI, get signaled by an automation system, and then gets an SDI feed with SCTE 104. Our inserters can be signaled by using SCTE 104 itself, by GPIO, or by some proprietary Cobalt protocols. All of that is available. Or you can talk directly to an encoder with SCTE 104, although the standards recommend it's better to do it at the inserter, right? And if you need to monitor that, the Cobalt decoders, all of them, can take a transport stream with SCTE 35 and make the SCTE 104 back for monitoring. So if you want an ad insertion solution from Cobalt, we are in the business of putting the markers on. We don't generate the markers. We're in the business to put the markers on. So we have SCTE 104 inserters that are SDI in and SDI out. We have encoders, which is SDI in and transport stream out. And something new, in the encoder, we now can put that on HLS as well. And we convert 104 to 35. So this is supported in all Cobalt encoders, but in the newer encoder, we can do that on HLS. In the decoders, you do that for monitoring, TS in, SDI out, and we put the SCTE 104 back into the SDI signal, supported in all Cobalt decoders. I'm going to change gears again and talk about RIST, because, yeah, we talked about SDI, we talked about transport stream, now we want to transport that transport stream over the internet. So what's the problem here? I want to use the internet to transport broadcast grade video because I'm paying for it. It's already there, not very expensive, and it's got gobs of bandwidth. However, what are the impediments to do that? The internet drops packets, so video may glitch. I would like to use multiple links or combination of links if I want reliability. Okay, that works, but what about latency, right? If I'm doing live, that's going to add some solutions add a lot of latency. The other point of this, I need my content to be protected. In fact, you may have a contract with the content owner that if it goes out of a facility, it needs to be encrypted, protected. A different problem, a different security problem is authentication. Bad people should not be able to hijack my feed. So if it's a reporter doing a live interview, it's got to be the reporter and not someone else that's hijacking it. And finally, there's always this tension with the IT people. They are busy. It needs to be very easy to set up. So what's RIST? RIST is an interoperable specification that ticks all these boxes, provides all these functions. That's what RIST is. And interoperable means you can buy equipment from different vendors and they all interoperate. So RIST is divided into profiles. The first one is called RIST Simple Profile. You have basic compatibility with non-RIST systems because we use RTP as the base protocol. It's something that's born for streaming. RTP is the base protocol. Now, you add to RTP NAC-based recovery, which sounds cool, but it's very simple. If a packet doesn't get received, it's retried. That's it. That's all you do. You don't acknowledge packets that are received correctly because most of the packets are going to make it correctly. You just ask for the ones you don't get. And you can then throttle the retransmission bandwidth for stability. So features of this method, it's bandwidth efficiency. So because you only send what you need, only retransmit what you need. And there's a tunable trade-off between latency and protection by basically deciding how many times you're going to retry a packet before giving up, essentially. This built-in has multi-link support and also IP multicast support. All right, then we move on to RIST main profile. Simple profile gets the content there. Main profile protects it. So the main profile features are encryption, which is if it's going out in the internet, it needs to be encrypted or people are going to steal it. Authentication, which is independent of encryption. Authentication makes sure that you're connecting to the endpoint you think you're connecting. And tunneling, because that makes it simpler for IT. You need to only one UDP port, and you can open it whatever is convenient for you. So, and the main profile can combine multiple streams into that single port. So that's what main profile gives you. I want to touch about the security options. Encryptions, we have AES-128 and AES-256. And you can disable and enable individual encryption options. This is because in some places of the world, you cannot do AES-256, it's not legal. And we don't want our customers to go to jail because then they don't buy anymore. Authentication is, as I said, very important. It's independent of encryption, and we support both the old RSA and then the new ECDSA, the electronic certificate, elliptic curve digital signature, which are the brand new ones. And on the Cobalt implementation, any Cobalt device can be the certificate authority, and we have a very easy web interface. People who have set certificate authority says, oh yeah, it's very difficult. We made it simple for you. Cobalt device will do everything for you. We have RIST support in the various Cobalt devices. In the latest ones, you have the full support. In the older ones, you may not have encryption, but the full matrix is over there. Every encoder and decoder from Cobalt is there. Now I will turn it over to Cris for product updates. Cris.
Great, thank you, Ciro. So to start off again with some of the new products that we have that are coming out to NAB. This is our HDMI to SDI conversion platform. This is a 9926. As you see here, this is a quad HDMI input to quad HDSDI or 3GSDI output. This particular one, as you see here, by default includes also frame sync, which is a nice feature if you compare it to whatever else the competition has. That's in some cases that's a premium offering for some of the other products out there in the market. Now, another thing that we offer with this product is the ability to do color correction. If you see here, the color correction can be performed or applied to any of those inputs and outputs because the card, even though it's a 4-channel, each of those channels are going to behave like independent cards within one card. So just having this sort of functionality in one card that has the discrete, 4-channel capability, now you have a certain density that if you were to have multiple cards in one frame, now you're able to properly convert and also color correct with frame sync many channels in a one 2RU frame size. So again, this is a very new and exciting product for us because it adds, a certain flexibility that some of the competition today does not offer. Next slide. And the other product that we have, which is on the opposite of the product that we just discussed, the 9927, this one goes from SDI to HDMI, and again, similar to the 9926, This offers the same capability to have the conversion, plus as a standard feature, you get the frame sync and the ability to have RGB color correction as an option if needed. So again, it's a very similar platform, but instead of having the 4 channels, we are limited to only 2 channels. So just keep that in mind. Next slide. And one of the options that we have now, as we talked about, first Ciro touched on Indigo for the 9904. Now a new license that we offer on the 9904 is the ability to have Dante, so we can properly process 16 channels as inbound or outbound. So you decide how you want to process that, but it's a very unique feature in today's basically workflow environment, where you have a mix of different audios, including AES, MADI, and now Dante. It's a nice feature to be able to support it on a platform that's already doing a lot of other processes. So again, just to be able to have a license enabled on this particular platform adds more flexibility, and certainly it'll give you a lot more bang for your money if you've already invested in this product. Slide.
Yes, thank you, Chris. We'd like to talk about, since we're talking about product updates, let's do an overview of the audio and video capabilities of the encoders. These 2 matrices show the different capabilities of the encoders. We have the 9223 series and the 9990 series, which are H.264.420 encoder only with 3G capability and dual channel. And our new 9992 encoder has been shipping for a few years, but yeah, we should call it new. It's a quad channel encoder with 4K capability and does everything from MPEG-2 all the way to HEVC and 8-bit, 10-bit, and 422. For audio, we have one of the best industry lineups of audio support with support for MPEG-1 Layer 2, all the AAC modes, Dolby AC3, Dolby AC3, and even a linear PCM, SMT302 linear PCM for ultra-low latency. Also, the 9992 encoder can do 16 channels of audio. It's actually pretty cool because you can now, the audio channels float and you can assign them to any of the video channels as you wish. Same thing for decoders. We have the 9990 decoder, the legacy one that does MPEG-2 and 264. It's a 420 8-bit decoder with a maximum resolution of HD. And the new 9992 decoder that can do everything, including HEVC and 422 and 10 bits with a 4K capability or a dual HD. This is probably the most sophisticated decoder in the market in terms of audio support, because again, it does everything, including it can decode Dolby AC4 and it can decode Dolby E. So if you have those difficult to decode streams with Dolby E where you have to throw a Dolby box in front, not anymore. You can do Dolby E on this guy. He will decode Dolby E for you. And again, a maximum of 16 channels, and will do surround directly for you. Since we're talking about encoders and decoders, I would like to touch about new features. On the 9992 encoder, we now have a built-in frame sync. So if you lose video, the encoder will continue to operate with a flat field or the last good frame. And it can encode 4 independent feeds without the need for synchronization. The frame sync support is built-in, is thrown in at no additional cost. Another very cool thing that we did is metadata auto-configuration from VPID. So we can read the VPID and set up the colorimetry and transfer characteristics based on VPID. So we don't need to know about that. And in fact, we can even change that dynamically for you. So if you're doing, let's say, HDR to YouTube, and your input signal is properly marked, you just click the auto button and there you go. Something that's very new as well is OP47 subtitle support for our European and Asian customers. In the 9992 decoder, we added a built-in up-down cross-converter, very good cross-converter for free. It doesn't cost anything more. You can convert any 4K or 3G to any 4K and lower to 3G or lower resolution and frame rate. It doesn't go up to 4K, but you can take any resolution and go to 3G or any frame rate, and it's going to do it for you, again, included at no cost. Same thing, automatic VPID configuration for metadata. So it's going to read the metadata and put the VPID out for you. We can also override that and do manual VPID configuration. And since we did OP47 in the encoder, we also did OP47 in the decoder. Cris, can you talk about the BBG 1300FR for us?
Yeah, so we have, this is one of the latest additions to the OpenGear world from Cobalt. This is our new popular BBG 1300 standalone enclosure that offers a lot of capabilities. So if you're used to working with an OGX or one of the HBF frames, this is no different. This behaves exactly like those bigger frames, but you have the added benefit that now you have portability. You essentially can fully control the frame through the front panel. As you see, it has dedicated controls in the front, but you can also talk to it through dashboard as you do with the other frames. And as you see there, the front panel is open because this allows the user to easily swap out any OpenGear car as long as the backplane is capable to be mounted in any OpenGear frame. This will support any of the other OpenGear cards that are non-Cobalt as well. So that's a nice feature with this frame. Plus, you get out of the box redundant power. You get full support for SNMP. You also have a ton of advanced networking capability with this frame. And if you wanted to mount, let's say, multiple cards, like let's say the encoder, decoder cards that Ciro just talked about, or the 9905, which has multiple channels, or even the 9926 or 9927 cards, you can have a certain density if you put 3 of these frames side by side in a 19-inch wide rack system or a 1RU space. Now you have a certain density that you can easily talk to these frames through dashboard, or you can, like I said, you can talk to this or control them through the front panel. So this is a very flexible platform that we think is adding a lot more value to the existing OpenGear world, where people can continue to use existing cards that they have in a traditional OpenGear frame. And if they need to expand to maybe a couple more channels, you can easily grab one of these and just put it on top of the other frames or in a rack with limited space, but to being able to have the same capability that you have with the other cards. So again, this is available, and we're going to bring this to NAB. And if anybody is wondering how this performs, I would suggest to look further into this, because this is certainly a very flexible tool that adds more value to a new OpenGear workflow.
Well, thank you, Cris, and thank you all for your attention to this. We hope to see you all at NAB, but you can always reach us at any time, or glad to talk to you or email you or follow up. So again, hope to see you all in Vegas. Thank you.
Thank you.